Hi everyone, this is ProFAX, the project we want to present at SIGDA University Demonstration at DAC 2016. We are Giulia, Lorenzo and Marco from Next Lab at Politecnico di Milano, and this is our demo. Let's start with an introduction to the subject, the protein folding. It is defined as the process of creating the three-dimensional structure of the protein, starting from a sequence of amino acids. The tertiary structure is useful as it determines the functionality of the protein. Nowadays' trend is to perform protein folding through homology-based algorithms. However, they are not useful for new protein templates. In fact, we want to be able to create new proteins from scratch. The algorithm presented here is Ab Initio. Given only energy and geometry feature, we are able to identify the 3D structure from the primary sequence. The main two components for Ab Initio folding are an energy function used to calculate the conformation with minimum energy and a way to explore the conformational space as Monte Carlo. But what is the problem? The problem is that the algorithm is computationally expensive. So here is our idea, ProFAX, an acceleration of Ab Initio protein folding algorithm exploiting FPGA. The main issue is that a pure software implementation is inefficient, as it would take too much time to compute. The solution proposed here is a parallelization of the algorithm on FPGA. Thanks to our system, the user will be able to submit unfolded amino acid sequences that will be sent to a server. The server will be equipped with an FPGA board that will compute the 3D structure and will send back the result to the user. Here is an overview of the implementation step we took. Firstly, we profiled our application in order to identify the most compute-intensive function. Then, we performed a stated code analysis to estimate the complexity of the kernel, and we used this value in the roofline model to estimate the performances. At this point, we created and optimized the kernel code, and we wrapped it to be usable on the SDAccel framework. SDAccel automatically synthesizes and implements our kernel into a hardware. The design can then be used on the FPGA. Now, let's talk about results. The first results we had highlight a good ratio performance over power consumption and halving of the execution time with respect to a pure software implementation on CPU. However, the design can be enhanced more by optimizing it further. So, thank you very much for your attention from the ProFAX team. If you have any question, please send us an email and check out our Facebook and Twitter pages.